Okay, example 6, finding complex conjugates. Still working with our complex numbers, where we have the real number and the imaginary number. To find a complex conjugate, you're going to take your regular a plus bi, and the only thing that changes for the complex conjugate of this is just the imaginary becomes negative. So you take your original and you just change the sign of your imaginary. So if I've got my original is 2 plus I square root of 5, my complex conjugate is going to be 2 minus I square root of 5. Okay, go ahead and try it for this next one. Pause the video and then come back. Okay, our real for this one, our real number is 0. So our complex conjugate, remember, is going to change the sign of the imaginary portion. So it's just going to become positive 1/2 I. All right. Find the complex conjugate of -3 plus 4i. Again, pause the video and then come back to see how I do it. Okay, the real number portion stays -3. The positive for the 4i becomes -4i. And there's our complex conjugate. You're going to need to know how to find the complex conjugate in order to divide complex numbers. So when they're asking us to divide 2 plus 5i by 4 minus i, that looks like this. 2 plus 5i divided by 4 minus I. All right, when you divide complex numbers, you have to rationalize your denominator, which means there should be no square roots in your denominator. Currently, we have an I, which is the square root of -1. So we can't have that because our denominators cannot have square roots. So to change it, we have to multiply by the complex conjugate of the denominator only. So if the denominator is 4 minus I, the complex conjugate is 4 plus I. So we're going to multiply both the denominator by the complex conjugate as well as the numerator. Because when we do that, anything divided by itself is 1. So we're not changing anything. We're just multiplying the entire thing by 1. All right, when you do this, you have to FOIL both the numerator and the denominator. Because remember, you multiply straight across. So I'm going to go ahead and FOIL these. 2 times 4 is 8. Outer is 2 times I is 2i. Inner is 5i times 4, which is 20i. And then last is 5i times I, which is 5i squared. Remember, our I squared is -1. Now we're going to multiply the bottom. 4 times 4 is 16. 4 times I is 4i. -I times 4 is -4i. And then -I times I is -I squared. We're going to go ahead and combine like terms and change our I squares to -1. So in our numerator, that's going to become 8 plus 22i. And then -5. Because remember, this becomes a -1 over 16. This is the reason we do this. These should cancel out. Make sure they cancel out so that you did it correctly. Don't just assume they're going to cancel out. These need to cancel out, become 0. And then -1 becomes +1. Now we just need to combine our real numbers. So 8 minus 5 is 3 plus 22i over 16 plus 1 is 17. Now, this is not currently an a plus bi format. We have a numerator combined over a denominator. We need to switch these out to 3 over 17. That is the real part of it, plus 22 over 17i. Now we have the real separated from the imaginary. That is the correct way to answer this. I'm going to pause the video and stop it and do a new one.